Okay, we have our second model in now, the one with better performance. And what surprises me, and I've run this a bunch of times, is that we're not performing all that much better. And I suspect the problem is that the BIM model is really not being accurately portrayed in this. And that could be from my fault of not making sure I have all of the settings set right, but I've looked at them relatively extensively. It's not obvious, and gone even through the help sites to try to figure this out. But let's not that. We'll get through what some of those issues are. Let's first look at how we can actually take a basic design and tweak it to perform better. So we've got the original visitor center, and we're still not achieving our goals here. One of the first things, and because we've listed all of our widgets, these are what these elements are considered as a computer term, because the widgets are in order of importance. The first one that we can probably do the most change on is change our air infiltration. The triangle is always the BIM import port, and then the next one is the ones that are on either side of it are worse performing and or better performing. So I'm going to ask that we're at a better performing standard. So we've tightened up our construction and our value has gone down. So that's the first tweak I made, and I'll make that to the other one also. Let's look at roof construction now. Here's our BIM, and it's right there between R30 and R38, and I really think that we're already performing better. I don't think it's reading our model correctly. So I'm going to just zoom this into R38, and that gives us a little bit of an improvement. And I'll flip these back around. So, well, you can leave them that way. It's just that it's a shame to lose the graphic. So wall construction, let's just take a look at what this is. Once again, this is a bit cryptic to me because our BIM model doesn't seem to have any kind of values associated with it, and these are only marginally better. And then some of the changes just become a little bit bizarre. So let's just tweak it. I'm going to go to this 14-inch or R14, well, it's 14-inch ICF, and that gives us a little better performance. And as you can see now, what's happening is every time we tweak the construction systems, we get a little bit of better improvement. Plug load efficiency. We're estimating that we have this at the BIM level, which is between $1 and $1.03 watt, or excuse me, not $1, but 1 and 1.3 watts per square feet. And we'll go ahead and we'll accept a little bit better performance here. And now what we've done is we've really basically achieved our efficiency goals to meet current standards. And that would be the minimum that we would need to do for our client to make our building perform right. The other thing I'm missing here is the heating system. I wonder what kind of, see, this says an order of importance, but if we were to stick a very high efficiency furnace in here, as you can see, we could get very good performance. So let's just do just a moderately high efficient package here, and we can get down to $1.87. All right. Now that, to me, that should have been up at the top if it was in level of order of importance. So we're now approaching our Architecture 2030. Let's just take a minute maybe. I don't know if I've reviewed this yet or not. These two standards, the ASHRAE 90.1, I've just called up on the Wikipedia, and it's an energy performance standard, mostly for basically commercial buildings. It's been around a long time. Updated, it looks like 2010, 2000 all the way to 2016 to reflect changes. So it becomes more and more stringent every year, and it's still a minimum standard. It's kind of what is expected in contemporary construction. On the other hand, that Architecture 2030 is an aspirational goal, and it actually has a website, Architecture 2030. And the idea is obviously getting to zero carbon emissions, net zero energy consumption. And it's it has a reach out to 2050. It's really designed to address carbon change or climate change, mostly based on energy consumption and carbon emission. So there's a whole site on this and what the aspirations are and what kinds of groups have made commitments to it. So that's like I say, an aspirational standard. That's where we'd like to get. And obviously it's not 2030 yet. So what we want to do is always be thinking about how we're going to move to that goal. So let's say we've now taken our visitor center and its standard construction and just improved it a bit. Let's now go back to Insight now. And you'll see that this one's already performing now better, and this is what's a little confusing than the one we specified with better materials. So I want to go through now and actually try to tweak this one also to improve its performance. Although this one comes, well, it's not really that much closer to achieving the standard. So let's look at the plug power consumption. Like I said, I don't want to get excessive about this, so we'll just go down one better than the BIM model. The roof construction doesn't seem right because we've got better than R60, but we're going to go all the way down there. Southern wall construction, we were already, see, now we're not even getting R values out of here, just different options. Well, this is amount of glazing in those windows, and that's really frustrating because the BIM model already specifies those schedules for where the amount of glazings we put in those sides. Lighting efficiency. Well, let's definitely tweak this up. I think we can, with LED lighting, we can get to very high levels of efficiency, and we've added a lot of natural lighting. Operating schedule, wall construction. And here's where we really have a very high performing wall. We'll build it tight like the other one. And then this one, which is a really important tweak, we're going to put a high efficiency heating system in. And maybe we should actually take it to the next level up. Window glass. Double BIM, and this is what we really have, is we have triple low E, so that's what we should suggest, or have in that south window. These are glazing areas, excuse me, so that was the glass. Let's do the glass on the west. And we shouldn't, to me, we shouldn't be having to make these settings. These should have been, we already should have assumed that we had this triple. That's what the value of the BIM model is. I want you to take note of my commentary. I want you to think about that also, because we're going to come back to this idea of stating what we think the effectiveness is. Now, we are already assuming, I believe, that we're going to have some kind of a photovoltaic, which is kind of a surprising I don't know, guess, but we'll leave photovoltaics unchanged so that they're both doing the same connection. So we've gone through and taken our best model and tweaked it to really reflect probably close to where we are. And if we look at it, we're really at half of the cost of standards today. So we really have a very high performing building. We haven't met the really stringent criteria of the Architecture 2030. But I think that's a good, and you notice you can zoom in on these, and you can actually ride over these to find out what actually changes were made to reduce the cost of that intervention. So I'm going to go back to Insight now, and you see we've now been able to tweak that down to better performance, but it almost seems to me immaterial whether you actually build a better model or not. I'm still searching for ways to pull the BIM data into Insight more effectively. It doesn't seem like you get any reporting out of this, so it's really hard to, I guess, generate some concise reports, at least for discussions with other people. So anyway, we're going to do one more thing, and I guess we could probably do it in the next clip. We'll look at the actual energy modeling performance that happens right inside of Revit.